All right, so today we're going to take a look at section 3.5. We're going to talk about analyzing arguments with Euler diagrams. And what you want to be thinking in your mind is about how we think about arguments. So one profession that would have, kind of hands-down reason to be working in this area would be the law practice, right? A lawyer. So when you're creating an argument, the idea is that you want to be able to get a buy-in. If people can agree with the first statements that you say, you want to create an argument that forces them to come to the same conclusion that you came to. Does that make sense? So if you can get them to buy into the way that the argument's structured, if the argument is structured in a proper way, then you'll have that happen. So the first thing we're going to talk about is whether an argument's valid or invalid. So a valid argument has that feel to it, that if all the premises are true, if somebody buys into the truth of the premises, the first things you said, then they're forced to conclude what you want them to conclude. They're forced to make the statement that the rest of it is true. Obviously, if something's not valid, it's invalid. Okay? It means that this isn't going to hold. It's not going to work. We're also going to work on, also going to use the language fallacy. Okay, so if something is invalid, it's called a fallacy. And we'll see that later today as well. And I need to tell you what Euler diagrams are. All right, so there's 3 types of Euler diagrams, and they look a lot like Venn diagrams. Okay? So let me draw you some pictures of Euler diagrams. One Euler diagram is drawn so that you have 2 circles. Okay, so there's no rectangles around things. Venn diagrams have rectangles around things. That's kind of the key difference visually here. All right? So one option is that one Venn diagram is that you could have one circle located inside of another one. A second option is you could have 2 circles that overlap. And then a third option is that you could have 2 circles that are completely disjointed. They're not connected at all. And I want to give you examples of when you could have, or ways that you could have these particular diagrams cropping up in arguments. So let me give you the first one. The first one could be something like this. We could say, all dogs are animals. And then our circles are going to represent the 2 different descriptors that are in that sentence. What are the descriptors that are in that sentence? Dogs and animals. So this picture would represent dogs as the inner circle and animals as the outer circle. In other words, if I were to bring Manny, who's my dog, into class, and I said, meet Manny, you would be able to say, Manny is a dog, so he's inside the inner circle, which means Manny is an animal because he's automatically in the outer circle as well. Okay? So this is one way to picture a Euler diagram. A second option is where they overlap, but they're not completely one inside of the other. So let's do an example that relates to you guys a bit. So some freshmen attend, I think this will work, OBU. So what are my 2 circles then? Freshmen would be one of them, right? And clearly, some freshmen do and some freshmen don't. And those are the 2 pieces of the circle. So the freshman that would not attend OBU would be out here, and then the freshman that would be attending OBU would be the overlap. What's this other circle then? Yeah, maybe OBU students. We could say that sort of generally, right? It's not just OBU, but it's a descriptor of OBU, so these are OBU students. Again, the overlap here is the freshman at OBU. What's out here? The upperclassmen, anybody who's not a freshman, right? They'd be over here in this particular diagram. All right, last one, the diagram where they are disconnected. This diagram would be something like this. No birds live at my house. Not exactly a fan of birds as pets. They're wonderful out in nature. What are my 2 circles? birds is one of them. And things that live at my house, right, would be the other one. So I know that's a little bit more writing, but these are things, I'll just say things at my house. Okay, so if I want to talk about the things that live at my house, we're talking about a dog, we can talk about my cats, we can talk about my kids, we can talk about some plants, but there's no birds in that mix. Okay? Now, there's a key word in each one of these phrases that tells you which diagram to draw. Can you see the keywords? That's right. All, some, and no. It tells you what the picture's going to look like. Keywords, they're very helpful. So when you see those words, it tells you how to draw the picture. Sound good? All right, so what we're going to do is we're going to work on creating some arguments based on Euler diagrams, pictures. So here's the first one. We're going to decide whether the argument is valid or invalid. I'll show you how to do that. We haven't done that yet. But we're going to do that based on an Euler diagram. Okay? And if I ask you to do this on the test, I will specifically say using an Euler diagram. I don't know if it'll say it in the book in this particular section, but considering this section's titled Analyzing Arguments with Euler Diagrams, that's what it means. Okay? So you should draw a picture on every single one of these. Everybody clear on that? Yeah? Okay, so no picture, no credit. Yeah? Okay. We're going to take the first sentence, and the first sentence is going to create for us an Euler diagram. And the first sentence says, all politicians lie, cheat, and steal. The key word is all, which means what are my circles going to look like? One inside and one outside. You got it. Good. So I'm going to start with a picture of circles or ovals or something where it looks like one's inside of the other one. What is the inside circle going to be? That's the politicians. Okay? So this is politicians. What's my outside circle going to be? Okay, people who lie, cheat, and steal. All right, there's my people who lie, cheat, and steal. Then I've got another sentence. So the first sentence created the Euler diagram. The second sentence is going to create whether or not the argument's valid or invalid. It says, that man lies, cheats, and steals. So what we're going to do is we're going to let that man be the letter X, or whatever you'd like. Okay, give it a name. And that's going to be that man. We could have given him a name, Joe. Joe lies, cheats, and steals. We could call X equals Joe. All right, whatever you give it, though, this is the letter X. Where is the letter X going to go in this diagram?
The outside.
The outer circle, that's one possibility. Where else could it go? It could go in the inner circle, but it has two different possibilities, right? We don't have a for sure description, but it could go in either of these places. Make sense? All right, so the last statement then, we've got a line that means this would then follow. Can we say for certain that man is a politician? No. Because one of those places where I put the X was not politicians, correct? They might be lawyers or something else. So this would then tell you, because there's two of these, and they're not both inside the politician's circle, this tells you that the argument is invalid. And you have to say what the statement is at the end. Remember the direction said decide if it's valid or invalid. So if you draw me a beautiful picture but you don't actually answer the question, that's a problem. Based on your diagram, you have to actually say if it's valid or invalid. And this one would be invalid as it's stated. Next one. Some nurses wear blue uniforms. Some nurses wear blue uniforms. D. Boyle is a nurse, therefore D. Boyle wears a blue uniform. So for starters, first sentence, keyword is some. Some tells me what do I do? You got it. Overlapping circles. What are the categories that my circles represent? Okay, persons wearing blue uniforms. That's was okay. Somebody said that one. So this is, whoops. So people wearing blue uniforms. Okay, my iPad's not wanting me to write things very well today. There we go. And what's the other one? I heard somebody say it, several people say it. Nurses. The other category is nurses. All right. And then we're going to do the same thing we did last time. We're going to let the letter X, or whatever you want to be D. Boyle. And what we're told in the second statement is that D. Boyle is a nurse. So where could the X go? Okay, so it could go in the middle, or it could go in the nurses only section. Either of those places would be appropriate with the information we're given. And then we have to make the claim, or we're trying to make the claim, D. Boyle wears a blue uniform. Maybe not, right? Because we do have D. Boyle as a possibility being out here, and there's no blue uniforms out here. Maybe she wears white or scrubs or something else that's not blue. So this would be invalid. I promise not all of them are invalid. Okay. Next one says all disc jockeys play music. Flash Phelps is a disc jockey, therefore Flash Phelps plays music. Okay, first line gives me the overarching picture that I need, right? All right, all disc jockeys play music. Keyword? All. Which tells me what does my picture look like? A circle inside of a circle. All right, what category is the inner circle? Disc jockeys. And in some sense, you can tell that that's what's going on because it actually comes right after the word all. The word that's after the word all is going to be the part that's inside. Okay, so if you're having a hard time sort of reasoning through which one should be where, that's a good rule of thumb, all right? Whatever comes after the word all is going to be the inside circle, disc jockeys. So what does the outside represent? People who play music. Now what am I going to do? Right, X equals Flash Phelps. And where in the world am I going to put Mr. Flash Phelps? In the very middle. And that's the only place for it, isn't it, Mason? Here's X. Because it says Flash Phelps is a disc jockey. So I can put him inside the disc jockey circle. If I try to put him out here, that's not going to work. Because the people out here are not disc jockeys. They play music, but they're not disc jockeys. So the only place he can go is inside the disc jockey circle. Okay? Now then the question is, can we therefore make the claim that Flash Phelps plays music? Yes. Because that X is located in the big circle that says people who play music, right? So is the argument valid or invalid? This one's valid. Okay, so the diagram supports my reasoning, but I still have to state that it's valid or invalid when I'm done. All right, number 4 actually does the opposite. It actually gives us a picture. Let me draw the picture in for us. It should have already been drawn. I apologize. The picture that you have on your paper, if you've printed this outside here says pet lovers. And the inside here says cat lovers. and there is an X on the inside. So it looks something like this. And what we're asked to do is we're asked to construct a valid argument based on this truth table, or not truth table, based on this Euler diagram. So we're kind of working backwards, right? We've got this picture, and we're going to create an argument with two lines, and then two sentences, and then a line, and then a therefore statement. The first line of your work, the first sentence, has to be about the circles. So looking at the circles, cat lovers, pet lovers, what can I say about the structure of my circles? Right. So my first statement is all cat lovers are pet lovers. Why am I using the word all? Yeah, because I got the double circle thing going on, right? That tells me I'm using the word all. And why do the cat lovers come first? Because that's the inner circle. So everybody in the inner circle is automatically in the outer circle, and we've written that description down. Now what? Oh, yeah, it says that on the outside. I didn't write that in here. On the outside of your paper, this says X equals, or X represents. Sorry, this is part of the given question. X represents Jessica Long. Okay, so Kaylin, you wanted to tell me what the next piece was. What should it say?
Jessica Long is a cat lover.
Right. Jessica Long is a cat lover. Why does that work for us with this diagram?
Because the X is inside.
Yeah, because the X is in the circle, it just says something about cats, right? Only in one place, we know where it is. Next thing you do is you draw yourself a little line here. Therefore what? Jessica Long is a pet lover. Because she's in the inner circle, by default, she automatically is in the outer circle, and the outer circle is about being a pet lover. So we can therefore make the claim that Jessica Long is a pet lover as well. Okay, got one more. Are you ready for it? Okay. Last example for today. Decide whether the argument is valid or invalid. What do you notice about this argument as opposed to the others? There's two alls. There's three statements above the line. Everybody see that? There are two sums as well. That's very true. Yeah, three different things that are happening here. All right, so let's start with the first statement. It says, all people who drive contribute to air pollution. All right, so what am I going to do? What am I going to draw? A circle inside another circle. What will the inside circle be? People who drive. I'm going to call them drivers. Okay? So people who drive are in the inside. What's the outside circle? Something about air pollution. So people who contribute to air pollution. Let's say contributors, let's do it that way, to air pollution. I'm going to abbreviate AP. Contributors to air pollution. That's the first sentence. The second sentence is another sentence with the word all in it, though. So let's take a look at the second sentence. It says, all people who contribute to air pollution make life a little worse. So ignoring the first sentence and what I've drawn already, what would this particular one be telling us we need to do? Yeah, I still need a circle inside of a circle because I got the word all, right? And the inside circle in my description would be, yeah, the bit about air pollution, right? That would be my inside circle. And what would be around it would be another circle which says people who make life a little worse. So I'm going to use the picture I've already got, and the outside circle right now is going to become an inside circle surrounded by one more, which is going to represent what? Whoops. Right. So these are people who make life a little worse. So far, so good? Circles inside of circles inside of circles. All right. Okay, we've done the first two statements. Now this says, some people who live in a suburb make life a little worse. So I know it's got the word some, and we could draw overlapping circles. We can also do the thing X, like we did before. Okay, so X can represent the some people, and that's probably the easiest way to draw it. So are we okay with me doing the same thing I did before on the others? Okay, so we're going to say that X is who? What is X? Suburban people, or people who live in the suburbs, right? So, and it's some people, you're right. So some people in the suburbs. Okay, so where will that X go?
Middle.
Here?
Not there, no.
No? Here?
Yeah.
It could go here, right? Where else could it go? Can it go outside of that picture? Can those some people go outside of the picture? Can they go outside of my outer circle?
Yes.
Those some people can't. Other people could, right? Other suburb people could, but these some people couldn't, because it says these some people making life a little worse, right? So we can't put the X on the very outside of the big circle. Could we put X anywhere else? Well, it's already in. Where do you want me to put it, Kat? Yeah, we got that piece.
Sorry,
No, you're fine. I want to argue that we could put the X in either of these places too. Because aren't those two X's also in the circle that says people who make life a little worse? Yeah. All three of those X's are inside of the big outer circle of people who are making life a little worse, right? So the X could go in any one of those places. The only place it can't go is outside of that. We all good with that? Okay. So our last statement then says, people who live in a suburb drive. Is it valid?
yes, because X is
It is in there, but does it have to only be located in there?
But it says some people.
What's that? Is that what you wanted to see, Mason? It says the same some people, and if you want to change the word some people, give you a person a name if it's helping. Okay? Joe. Joe, who lives in a suburb, makes life a little worse. Joe, who lives in a suburb, drives. There is an X in the middle, but only because it could be in the middle. Does it have to be in the middle? No, which makes it invalid.
Because it can only be in one circle for it to be valid.
Correct, or in the circle that it's describing, yes. So the issue here is that any of these X's are possible places that Joe or these some people could be, right? They could be in any of these three possible places, but we don't know which one they're in, correct? Because we don't know which one for sure that they're in, we don't know for sure that they're in that inside that inner one where it says people who drive. It's kind of like Dee Boyle, right? Back there on that nurses thing. We don't know which one she's in. Is she in the nurses over here that don't wear blue, or is she in the nurses that do wear blue? So we put an X in both places saying these are both places she could be. And the question then is, do we know for sure she's in one of those locations? And the answer is, no, we do not. Same thing here. These all X's are actually places where X could be, based on the description. But we don't know for sure that it's in one of those specifically. In particular, in this case, the drive part. So this would be an invalid argument. Could these some people be drivers? Yes. Do they have to be based on this argument? No, not based on this argument. Okay?